DHCP configuration. This nugget is the first of two nuggets about DHCP, and here we'll start off with the discussion of the configuration of DHCP. Really, we have to understand, first of all, what the advantages of DHCP, of which there are several. And I think after you start using DHCP, if you haven't in the past, you're going to like the time that it saves you and the headaches that it saves you. We'll also take a look at something called DORA. No, that's not a person. That's actually an acronym that relates to Discovery, Offer, Request, and Acknowledgement in the DHCP process. Now, it's important to know something about that because it might be useful in troubleshooting, and I'll show you how to look at packet traces or packet information so that you can know how to read that properly. Then we'll actually just install and configure DHCP, and part of that configuration will be to authorize the server, and this helps us to avoid what we call rogue DHCP servers. We'll also take a look at the various options that are available, such as what kind of DNS server, rather what IP address for the DNS server you want, what your default gateway is, and various other options, of which there are many. And we'll take a look at reservations so that you can guarantee a specific IP address to a specific client. Well, when you think of the advantages of having a DHCP server, I'm not supposed to be crossing that out. I'm supposed to be underlining that, by the way. Anyway, one of the advantages there is just easy administration. I had a friend of mine back in the early 90s that worked at a major university. He was an intern at a major university back in Colorado. And back then, and I don't know if it's really still true for a lot of places now, but for a long time, a lot of major corporations and government institutions and universities had real hesitations about using a DHCP server to automatically allocate addresses. Because a DHCP server will just give out an IP address most of the time to whoever wants one. You could be an internet stranger, you could be a hacker, you could be anybody who can plug into a jack in the wall within the environment. Well, so a lot of people had some security concerns about that, and so they would require that all hosts on their campus had only static IP addresses. Well, my poor friend. He had to go around during a winter break, during a snowstorm in Colorado one year, to all of the departmental servers and workstations, statically enter in a new IP address for the new IP addressing scheme, write it all down on a legal yellow pad, run back to his main office there, enter it into a database, and he did that for the entire spring, or for the entire winter break, and wow, wasn't that a big job. Well, DHCP would have figured all of that out and made it all real easy for you within moments. So you can see how that substantially makes the administration easier. Also, it has a big effect on human error. What if my friend accidentally entered in the same IP address on two hosts? Well, that's going to be difficult to track when someone comes back from winter break, starts up those two hosts, and they both get messages they have IP conflicts. And if no one actually is there seated at a machine to see that there's a conflicting message, then you have to track that down as an administrator to where those machines physically are. Not necessarily an easy thing to do. Also, there's consistency. I mean, you can have within a DHCP scope, which is a range of addresses and a range of configuration that we'll also be using, you can have consistency across the network, and again, you have that interaction where you avoid the human error here because you won't accidentally enter in the wrong DNS server's IP address in the scope options. We'll also have redundancy because you can have more than one DHCP server so that if one goes down, then you don't have the whole network off and unable to obtain an IP address. You'll have another DHCP server around somewhere that can still service those requests. And then you will not have issues with IP address conflicts as well in most circumstances. I mean, someone could come in with a statically configured IP address on a laptop, I suppose, and have a conflict with an existing DHCP given address on the network. But as far as what DHCP does natively and by itself, since we don't have problems with human error in its distribution of the addresses, we don't have any conflicts anymore either. Now let's address what happens when a client gets an IP address from a DHCP server. First of all, I've got a DHCP server over here and a DHCP client over here, and this maybe is a Windows XP computer that I just installed that doesn't have an IP address yet, so when it comes up on the network, it notices that it's got IP installed, TCP IP installed, but it doesn't have an IP address yet. So it knows that it has to send out what's called a discover packet. And these are all broadcasts that take place. The discover packet is listened to by everyone on the wire, but only the DHCP server can respond to it. And when it responds with an IP address out of a pool of addresses that are available, as well as all the other configuration information such as the subnet mask, IP address of the DNS server, Win server, default gateway, all that kind of stuff. Now, this client will then get that packet. This is also a broadcast packet that this client will respond to because the MAC address of this client is in that offer. And then it will send back to the DHCP server a request saying, hey, that address looks good. Please send me back or give me that IP address and all that information. So then the server will send back to the client an acknowledgement. And after that, this client will then have the IP address and all the other configuration that goes along with it. Now, we'll talk more about DNS and dynamic DNS later on. But after it gets this process completed and it gets its IP address, it will also dynamically register a DNS host record with a DNS server. Now, at a point in the past here, I went ahead and did a network monitor packet trace of the discovery, offer, request, and acknowledgement in process, and that way we can show it to you here in Network Monitor. Network Monitor simply captures packets on the wire, and there's two kinds. One, which is actually a version from SMS, is promiscuous, meaning that it captures all packets on the wire, and then the one that comes with Windows Server 2003 is not promiscuous, meaning that it only captures traffic to and from this actual network host. In any case, here we have all we need because this server at a point in the past had been a DHCP server, and I captured the information here. We have a discover, offer, request, and acknowledgement. And by the way, you can see there's kind of an acronym there, DORA, if you want an easy way to remember this. So just think of the woman's name, Dora. Not Dory, like in Finding Nemo, mind you. Just discover, offer, request, acknowledgement, Dora. And then down here we see what's going on. The destination address that it's sending this broadcast out to is, of course, all Fs. That's hex equivalent to the all ones that we see in 255.255.255.255. And remember from a previous nugget I said that all ones means a broadcast. Now, let's go ahead and further on down here take a look at some other information. Here's the decimal equivalent of that broadcast. That's the destination address of all ones, like I just mentioned. Now, if we go on further down, we see that indeed it is doing a DHCP discover message type. So it's trying to find one. Here's the source of the broadcast, this MAC address, which is a Windows XP client elsewhere on the network. Notice that it's actually requesting a specific address if possible, and that's 10.10.10.22. This will happen if, for example, you had a static address of .22 on that client in the past, and you're just now switching over to DHCP. Well, that machine will remember what its IP address was in the past, and so it will try to request that same address if it can when it gets an IP address from the DHCP server. And it's up to the DHCP server to allow it to get that address or reject that request. If there's another host that already has this leased, then of course it'll be rejected. And likewise, if the DHCP server at some point in the past has already leased another address to this same MAC address, to this same client in the past, then it will override and give it that old DHCP leased address, provided nobody else has already got it. In this case, since no one else already has that address and it has not released the same address at a point in the past from the DHCP server, it'll just go ahead and get .22, and in fact, that's what happened. Here we also see the client name of client 01, the host name of client 01. All right, then as we move on to the DHCP offer, we see that again it's broadcasting, but this time from a different MAC address, which is the server's MAC address. And we move on further down to some other pertinent information. There's the IP address of that DHCP server. Then we go on down to the DHCP offer itself, and we see that it is attempting to offer as your internet address, that's YIADDR, tongue twister there, 10.10.10.22. Hasn't actually accepted it yet, but that's what it's offering. And this is the source address. Then this is the client's Ethernet address. That's how we verify that indeed this offer is going to go to the proper client because it's identified in the MAC address there. Now the option field here, the DHCP option field, is where we get the meat of what we're looking at here. It is a DHCP offer offering this subnet mask and the 10.10.10.22 address that we saw a little bit earlier up here. And then it's coming from this DHCP server. It's going to offer this router address, going to offer this DNS address, and it's going to lease this address to the client using that subnet mask for 8 days. At the 50% point, which is 4 days, it'll attempt to renew the IP address. And then there's rebinding at 7 days. Now, this might not be used. Some people misunderstand this to be another renewal. Well, no, it's not a renewal. It's a rebinding. This means that if the client attempted to renew its IP address at 4 days and then was not able to contact the DHCP server for some reason, then at 7 days, it will attempt to recontact just any DHCP server to get an IP address. And that's what the rebinding time is there. And then we get our lease time of 8 days there. Now, then none of this is actually accepted, including the IP address that we saw up earlier in here, until the client actually requests it in the request packet. And in the request packet, we see that again it's broadcasting, but it's going to this specific MAC address, so the client's going to receive it. Let's go back down here now to the bottom part of this again. And at this point, we see that here's the actual request itself, again to the client MAC address, IP address requested. Here's the specific IP address of the DHCP server. That comes in handy later on because if you do a DHCP renewal using ipconfig/renew, it attempts to get a renewal from this specific IP address instead of broadcasting. And then that would help to cut down on network traffic. And that's also what it's going to do. It's going to use this address when it renews at its 50% lease duration and at its 7-day lease duration renewal. And then finally we confirm with the acknowledgement, which is just really a confirmation of all the information that it was receiving earlier, the lease duration, the IP address and subnet mask, and all the other information that you see down here. Well, enough about the theory of DHCP and all that kind of stuff. Let's just go ahead and do it now. Okay, how do we do this? Well, it's not installed by default, so you have to install a DHCP server by going to your control panel on the Start menu, and then Add Remove Programs. And once you get into this, you'll go down to the Add Remove Windows Components. Once we click on that, we'll be able to choose from among network options. So let's just go ahead and scroll down here until we get to Network Services, and double-click on that. That brings up this option where you say, I've already got DNS installed. Now I'll install DHCP, and then just next and let the files copy over. And when it's done, we'll have ourselves a DHCP server here. All right, it's gone ahead and finished that installation now. So now when I go into my administrative tools, I should have an item here now that's DHCP. So click on that, and we see that we indeed have our DHCP server with a red down arrow. That has significance. And it means that this DHCP server is not yet authorized. In Active Directory domains, a DHCP server from Windows 2000 or Windows Server 2003 must first be authorized in order to be able to lease IP addresses, or in fact, even to be able to respond to a DHCP Discover packet. Now, what's the purpose of authorizing a DHCP server? Well, that's to avoid what we call a rogue DHCP server. A rogue DHCP server is one that's been introduced to the network that the network administrators don't actually want there, and it'll start issuing IP addresses to my clients that I don't really want to happen. And this happened in a company I used to work for years ago where we had an existing DHCP server issuing addresses. This is the days of NT4. And then someone would introduce a test DHCP server accidentally on the network, and then you'd have DHCP servers, two DHCP servers issuing addresses, and the network gets to be a mess, and you have conflicting addresses and all different kinds of stuff going on. So can be a real train wreck in terms of DHCP servers if they're rogue. By authorizing a DHCP server, as long as it's Windows 2000 or 2003, then it will not be able to issue IP addresses until it's been authorized manually by an administrator, by someone who takes that little extra step to say, do I really want this on the network? Oh, you know what, I really don't, so I'm not going to authorize it right now. So it gives you that little bit of a hitch there to make you think about it. Well, this also kind of begs the question. I mean, since you have to authorize it in Active Directory, what if you bring up a Windows 2000 or Server 2003 DHCP server that's not a member of Active Directory? In other words, it's not a member of the domain. Well, if that's the case, and it's the only DHCP server on the network, it will lease IP addresses and configuration just like normal. It'll be just fine. But if you introduce then subsequently another DHCP server that is authorized on the network, then that first DHCP server that's a workgroup member will detect that authorized DHCP server and immediately stop its own DHCP service. Now then what we need to do is we also need to have a scope to issue IP addresses. I mean, right now, even if I were to authorize this DHCP server, it wouldn't have anything to do. So what we do with this is to right-click on the DHCP server and choose New Scope. Here we start a little wizard now, which we just kind of next finish through, and it's pretty well explains itself. We'll just call this Nugget Lab Scope, for example. And you can get a description there if you want as well. Then I'll just enter in the starting and ending IP addresses. We're on the 10.0 network, so we'll do 10.10.10.1, and then 10.10.10.254 as the ending address with a 24-bit subnet mask, which you see automatically fills in the appropriate subnet mask. So then we can go ahead and click on Next, and we enter in any exclusions. Now, what's an exclusion? These would be addresses that I want the DHCP server to have within its scope, but that it never actually issues to any of my clients. So I can enter in, for example, 10.10.10.1 through 10.10.10.2 20. And that would be maybe a common thing to do if I had the first 20 addresses set aside for static addresses for my DHCP server, for my DNS Win servers, my gateways, my printers, all that kind of stuff. By the way, you do need to assign a static address to your DHCP server, because if it has a dynamic address, it just plain won't work, and you can't even open the DHCP console to administer DHCP. So, hands down, must be static IP address. Now, what's an alternative to this? I could add this exclusion like I'm doing in this step, or in this previous step, I could just start at 21. You know, that would be pretty much doing the same thing as having an exclusion. In any case, we'll just go ahead and use the exclusion so we have that to do, and then we'll click on Add, and you can add additional exclusions if you want as well. Then we'll go ahead and click on Next. Here's where we set up the lease duration. It's 8 days by default. I'm okay with that, so I'll just go ahead and click on Next. Now, you might need to really consider this, however, if you have networks where you have a fleet of salespeople that come and go with their laptops, and every day they're in a different office getting different addresses. Well, if they're not going to be in the office for the next 8 days anyway, I might just give them a lease duration of 1 day if they always plug into the same segment when they come into my office. Because otherwise, they'll have IP addresses leased out for a period of time that they're not actually going to be using them and could potentially waste IP addresses. But in our case, 8 days is all right, so we'll just go ahead and next that. The next thing you'll see here is the option to configure various DHCP scope options. Now, you can also do this directly from within the interface of the DHCP console. I'll use the wizard for now and show you how to do it manually a little bit later on here. So if you want to configure these options now, you just simply say that you want to, and then you enter in the router IP address, or the default gateway of 10.10.10.1 in my case, and we'll just add that in. Add more if you need to. Then we'll click on Next, and here we can enter in the parent domain. This is going to be the names that we're going to want our clients to use for any name resolution. We're okay with not entering that in our case because we already have our primary DNS suffix, and I'm going to configure the DHCP server here, or rather the DNS server here, 10.10.10.20 actually is what it is, and then add. Now, if you didn't know the IP address, by the way, let me show you this over here too. If I didn't know the IP address of my DNS server, but I did know its name, then I would enter that in, DC Nugget 1, and then I could just hit resolve. Oh, that's what its IP address is. Okay, then we'll add. And then we just click on Next. And then we enter in any Win servers, of which I have none, so I'll leave this empty, but you can see pretty much how to do that as well. And then you can say whether or not you want to activate the scope. I'll go ahead and click on Yes, and then click Next and Finish. And once that's done, I can go to the scope here, and I can go to the properties of the scope if I wanted to make any changes to the starting to ending IP address. Notice that I can't, however, change the subnet mask. I can also change the lease duration, clear up to unlimited, and add a description if I want to. In the address pool, it shows me what my existing address range is. If I want to change that, again, I'd have to go to the scope properties to change that. The IP addresses that I've excluded, oops, what if I made a mistake? What if it's supposed to be only .1 through .10? Well, in that case, what I would have to do is to right-click here and choose Delete to delete this exclusion range, because you cannot modify this. There's no properties that you can adjust. On the other hand, I could also add a new exclusion range if I wanted to exclude, let's say, 10.10.10.250 through 254. I can just right-click and choose a new exclusion range here if I want. And then under address leases, I don't have any leases because I haven't leased any addresses yet. Plus, my server's not even authorized yet. Now, in order to authorize it, this is real easy. You just right-click on it and choose Authorize. There you go. That's pretty much it. By the way, let me point out that my arrow turned green right away here. Much of the time, it'll stay red even after you authorize it, so just be aware of that. And even if you click Refresh, a lot of times it still won't show green yet. It is authorized, it just doesn't show up in the interface sometimes. It kind of lags. Let me go ahead and go to another machine real quick and renew an IP address, and then we'll see that over here in Address Leases, if I refresh the screen, that I have indeed renewed the IP address of 10.10.10.22 to client 01. Now, I'll address reservations a little bit later on, so let me skip over that for the time being and come down here to Scope Options. Now, with this, I can double-click on any one of these items, and it just opens the common interface for the Scope Options. We really have the two most common items that we'll have there, and probably, in all likelihood, that's all you'll be using, is the router and a DNS server. Possibly also Wins, but most likely just these two. There are dozens of other options that appear here that are kind of esoteric and that don't really have much use in today's networks, but Microsoft makes them available to you if you need them. And if you do need a Wins server, then you would go down here to 44, Wins NBNS servers, NetBIOS named servers, and you'd enter in the IP address after you check on this item here. And then you can also go down here to specify the node type, and this has to do with whether or not it broadcasts to find a name first, or whether or not it uses a Wins server to find the name first, and so forth. And then you will enter in a value for this option as well. Now on the Advanced tab here, we have DHCP standard options, and there are, again, dozens of options there, but I want to point out a few options that are Microsoft options that you might find useful. One of those is the Microsoft Disable NetBIOS option. Remember I talked about some vulnerabilities with NetBIOS earlier? Well, you can disable NetBIOS on individual systems using TCP/IP properties, but if you want to disable it for all DHCP clients for this scope, you can simply select this box to disable NetBIOS on those machines. Again, make sure that you don't have any applications that depend upon NetBIOS resolution. And then you can also release the DHCP lease on the shutdown. You see, normally when a Windows computer shuts down, it still retains its lease. The DHCP server still identifies it as a leased address. And then when that client comes back up again, it'll simply renew its address when it starts back up. Well, in some cases, you might want to just explicitly release that DHCP lease when the client shuts down. This especially would be the case if you have, again, for example, people that come into your office all the time and then they leave, and they're not permanent employees or anything. They might just be contractors that go from one office to the next or something like that. And as long as they always use a common segment within your network where you're leasing a scope of addresses, you might just always cause it to lease if you don't expect to see those people come back on a regular basis. Another implementation I can see of that would be where perhaps you were administering a wireless access point in a public place and people come in with their laptops to get, free internet access for a reasonable period of time or something like that. Well, when those people leave, again, you want to have them release their DHCP lease. Now here's the strange thing with this. Under the Microsoft options, it says that it works for Windows 2000 clients to release their lease on shutdown. Doesn't work. If you really want this to happen, you actually have to go to the Microsoft Windows 2000 options, where it gives the same description for Windows 2000 clients. If you select this checkbox, then it does work, and it works for Windows 2000 XP or Windows Server 2003. Now then, we also have server options. Well, what's the difference between scope options and server options? I mean, you right-click here, configure options, do a route. It looks like the same thing. What's the big difference? Well, it has to do with the order of precedence and the purpose. You see, server options, anything I configure there, maybe a DNS server, for example, that would be a global setting that would apply to all scopes that I'd configured. And of course, I only have one. But if I had 2 or 3 or 4 scopes listed here, then those server options would apply globally to all of the scopes. What if, however, there's a conflict? What if I have, as a DNS server, 10.10.10.4 under server options, but under my scope options here, it's 10.10.10.20. Which one wins? Well, the specific scope option would override the global server options that we have here. And then we have an even higher level of precedence if we go into reservations, and I'll talk about that shortly here. A reservation, if it has certain options for a reservation, they would override both the scope options and the server options. So let me say that another way. Server options are overridden by scope options. Scope options are overridden by reservations options. And also, that's only true if there's a conflict between the settings. If there's no conflict between the settings, then they are cumulative, and you get server options plus scope options plus reservations. Now, let's get a little more detail about what a reservation is. You might have certain servers on your network that you may have a lot of them, and it might be quite burdensome to go around to each one of them and statically configure addressing. You might even have dozens or hundreds of servers. So what you might want to do instead is to use a reservation, which would assign a specific IP address to a specific MAC address. And that way, your servers would never, ever have a different IP address. So they wouldn't accidentally lose their lease on one IP address and then lease a new IP address and then cause some confusion within your network. And then the other advantage of a reservation then is it really is effectively the same as having a static address, but all of the options will also go with the reservation. This means then that if I were to change, my DNS server to 10.10.10.5, then anything that has a reservation would also get that updated scope option here on those clients. Now I've talked about reservations and what they are. Now let's go ahead and create one by right-clicking here and choosing New Reservation. And I'll just call this whatever's friendly to me. I'd rather just use the name of the computer that's going to receive this reservation. So I'll just do client 01. And then I'll enter in the IP address that I want client 01 to receive, which in this case will be 10.10.10.23. Now my problem in this case is I don't know the MAC address for that particular client yet. So what I need to do is to figure that out, and I'll go to a command prompt to do that, and I'll just do, I could do a number of different things. If I don't want to walk all the way over to that other machine that I'm trying to locate the MAC address for, I could ping it first by name or by IP address. I'll just ping it by name if I don't know the IP address yet, so ping client 01. Brings back a 10.10.10.22, which remember ultimately goes back down to the MAC address. So now this is going to be cached in my ARP cache, so I'll be able to do ARP-A, remember this from our last nugget, and I see I've got a 10.10.10.22 at this MAC address, and I'll right-click up here and choose Edit, and then Mark. And the reason I'm doing this is because I want to copy this and paste it, because I'm too lazy to try to memorize all those hex numbers here. So I'll just go ahead and select this number and press Enter to put it into the clipboard, and that's how you do that from within the command prompt window. Then I'll go into the MAC address field here, press Control-V to paste it in. It does enter in the dashes. You don't have to enter them in. In fact, once I click Add and I'm finished with this, it actually removes the dashes automatically. And then I can enter in a description if I want. What kind of types are supported? I could just do DHCP only, which would mean that this client would have to be on this local subnet because it'll do a DHCP broadcast only on the local subnet, only be good locally here. Or I could do a boot P only, which would mean that it would work across a boot P router, which is designed, if you so configure it, to forward DHCP discover broadcasts across the other side of a router. For most purposes, both is just fine, so I'll just go ahead and leave it at that, and then I'll click on Add, and then Close, and now I've got my reservation. And notice that also, if I double-click on this, it inherits the scope options from the scope. So here's the scope options that we have right here. By the way, let me just quickly show you one other way of getting a MAC address, just if you don't want to use the ping, and then a second command of using ARP. If you want to use a single command, you can just do a get MAC, and then /S, which will designate which remote server you want to identify, and then the name of the client or the server, client 01, for example. And then that'll give you the MAC address immediately on the next line here, which you see right there, the physical MAC address. Then you just copy that and paste that in, and you're back in business. And of course, I could change these if I want or add additional options. Now let's go back up here to address leases, where I see that I do have this address lease, but it's currently inactive. Now, offline where you can't see over here, I'm going to go ahead and configure this to automatically receive an IP address, and I'm going to have it go ahead and get an IP address from this DHCP server. And then coming back over here now, I will go ahead and refresh the screen, and we should see that now become, whoops, if I don't click on the help system here, now we see that it's become active because it has been released out to that particular client. Now here, let me point something else that I did. Offline here, I went ahead and finagled around with some systems here, which is a technical term, meaning that I misconfigured them deliberately to produce a bad result so that you can see something in this. And that's what pops out at you probably pretty obviously right here. Bad address. Boy, that looks like a problem, doesn't it? Well, you see, what happens here is I configured a system to attempt to lease the 10.10.10.21, which is an IP address that's already statically given to another system on my network. And what happens when a client tries to lease an address, even after that whole discovery, offer, release, acknowledgement process, is that we'll then also do an ARP broadcast, and it'll say, who has 10.10.10.21, because I just got this new address, and I want to see if somebody else has already got it and it's going to cause a problem. So that's why it sends out that ARP. And then the destination machine, which might already have that particular IP address, will also ARP, and with that ARP exchange, we'll be able to identify that there are conflicting addresses, and you'll see that on the screen, on both screens actually, if they're Windows systems. They'll tell you that there's an IP conflict on the network. In fact, you'll even get that on a system that has not been logged onto, that's still at the Control-Alt-Delete screen. That's a serious enough message that Microsoft will pop that up, even without anybody being logged on. Then DHCP also notices this, and then at that point it will not be able to lease that address to that client, at which point another attempt will be made to lease an address to the client, and it'll go up to the next available address. Well, 21 was bad, 22 is statically assigned to another server that I've got, 23 is assigned to the client 01, so the next available address that it can give out was 10.10.10.24, and that in fact is the client that was attempting to lease the address. And so that just explains what you might be able to see, what this means when you see this bad address item. Now, the other reason why that is in here is that it doesn't just detect a bad address and then just ignore it for the future. What it does is it enters it into the address leases section here so that it will no longer attempt to lease this address to anybody else that wants it. And any addresses that are in this section will not be leased to any other clients. In this nugget, we took a look at DHCP configuration, and specifically at the various advantages of DHCP. The primary advantage of which you'll see is that you don't have to statically configure hundreds or thousands of addresses anymore. Now, we can use DHCP to automatically distribute the addresses and configuration with really very little effort comparatively. Then we also took a look at the discovery, offer, request, and acknowledgement process, which is very useful in identifying how a lease is actually given out. We also took a look at how to install DHCP as well as how to configure all the different configuration options. And we also saw how to authorize a DHCP server, which helps to avoid rogue DHCP servers on the network. Now, this will not help prevent Linux DHCP servers or other versions or other brands of DHCP servers, but at least it prevents any Windows 2000 or Windows Server 2003 rogue DHCP servers. We also took a look at the various options for a DHCP server, of which there are dozens, but we looked at a few key ones, and then looked at the reservations for DHCP as well, and how to guarantee that a specific computer, or a specific network card actually, always gets the same exact IP address. I hope this has been informative for you, and I'd like to thank you for viewing.